Good afternoon. I think one of the challenges is post-lunch getting people in, and then when you have a very big hall like this one, it's not so easy to fill it up. But good afternoon, and thank you for joining me. My name is Sanjay. I head global business development at Huawei, and I'm also the global CTO, so I work between the markets and innovation for our data center play. Today, I'm going to spend time in sharing with you how at Huawei we are looking at and addressing the business and the opportunity of building a low carbon infrastructure, especially in the data center space. There's an old African saying, an antelope in the jungles of Africa, the thought of the antelope is to run faster than the cheetah. Because if it is not fast enough, it'll get eaten up. At the same time, the same cheetah's thought also is that if it doesn't run faster than the antelope, it will go hungry tonight. And so being fast is extremely important in the wild. I think that holds very true today in the data center space. Being ahead, being out there very quickly to meet the unprecedented demand that we see in the data center space is probably the play right now. There's a massive surge in terms of computing power demands. It's of course being driven by multiple technologies. The base is of course the digital transformation journey, everyone moving to the cloud. So that's obviously huge. Mobility adds to that. We all are ridiculously consuming data, producing data all the time. And so clearly that is driving a lot. Industrial IoT is another layer that is generating a lot of data. I was flying to France a few weeks back on the Emirates 380, and they have a bar at the back. And I happened to meet an Airbus engineer. And we were just talking, and he was sharing with me the amount of data that Airbus 380 generates, and that is transmitted back to Airbus service centers. It's in gigabytes. So the whole industrial IoT play is driving huge amounts of data. And in the last few years is the culmination or the beginning, if I may, of machine learning and AI. Machine learning AI has been there for a while, but it's now getting into a space where we have the right hardware, we have understanding of learning models, and we have business applications. In fact, we've been using AI over the last few years already. They're part of a lot of automation and bots that you are using across your businesses. GPT, as it is called, generative pre-programmed transformers. We all know it as ChatGPT, which is more a voice-enabled generative programming transformer. This is nothing but the ability to transform the learning into a pre-programmed play, which then can be fine-tuned and applied. To give you an idea, for a large language model, it roughly would take about 3.5 kilos to 4 kilo petabyte of data, or petaflops of processing to run a cycle of an 8-hour cycle. To fine-tune it would require another 1,500 to 1,800 petaflops. And then to actually implement it or operate it would require, depends on the application, between 7 kilo to 10 kilo petaflops. That's seriously huge amount of processing. And that's where compute comes in. And today what we are seeing is a huge demand for compute. And this compute is thus driving the extensive play in data centers. Not only this compute is growing in terms of size, but this compute is also uniquely different than the traditional CPUs, because most of the stuff here is GPUs, or a combination, as Google calls it, TPUs. And the power density is much higher. We are today looking at 400 watts to 750, 800 watts per chipset. And that is resulting in huge amount of power consumption. So today, to have a 40, 50, 60 kilowatt rack is a normal conversation. I mean, I've been in the industry like many of you for 30 plus years, but in the last 5, 7 years or 10 years, the kind of very quick evolution we are seeing in terms of the load factors, the demands of the customer, the scale is unprecedented. Someone recently shared that till about this year or last year, we have about 35, 40 gigawatt of data center footprint globally. And the expectation is another 35, 40 gigawatt in the next 5 years. So there's no dearth of opportunity right now in terms of the data center space. But then that clearly also brings in challenges. Not so long ago, 2, 3, 4 megawatt data center was a big data center. Today, average one pod is 15, 16, 30 megawatt. A campus is 400, 500 megawatt. And for that kind of demand and that kind of power, I don't believe any country, any city, the utilities are designed or even they have the plans to address such big requirements of power. Not to mention of space, the demands of local resources, and especially if you are in hot weather, will you be able to provide water for cooling and so on. And so the challenges now are very real. PUEs were worse before, but they were not so much of a challenge because the volumes were very less. If you're talking 2 megawatt, 3 megawatt data center, if your PUE is worse, you're consuming water, you're not disturbing the ecosystem. But at half a gigawatt, there's no more water available for you. And so clearly today, carbon neutrality, everyone is focused by country, by region, by company. The issues of speed, agility, issues in terms of efficiencies are paramount today. And not to mention all of this without compromising the service availability of the business. So at Huawei, in our journey in this business, we look at this dimension on 4 axes. How do we make data centers green? How do we keep it simple? Because that's the only way we can get both speed and predictability. How can we add smartness to the data center? Because at the scale at which we are working, we clearly need a lot of automation to manage this level of CapEx and asset. And finally, how do we further improve the availability, reliability of the infrastructure, and of course, of the people? So, the word green is very clear in terms of what it means, but it's not as simple. It all starts with the source of energy. And today, in the last decade and a half, a lot of investment has happened in terms of renewable energy. Photovoltaic being probably the largest, fastest contributor in this space, simply because ease of access and very simple deployments. And of course, also much lower capex per megawatt as compared to any other renewable energy source. But so this is clearly a huge advantage, and Europe has been at the forefront in a lot of the renewable energy plays. But that is only available for the hours the sun is out there. And especially, I live in Dubai, so probably I have more hours of sun per year. But clearly, again, that's only available during the day. And this is where grids have a problem. So currently, in the last 3 years, I was just reading a white paper written by someone in Europe. It's not so much a problem of, can I get green power? It's a problem of, can the grid handle and transport this green power to the consumers? So green power challenges are quite seriously out there as of today. The second is energy storage. Even if you have green power, the fact that power consumption through the day is very different. What is unique about data centers is that the load factor in a data center is very stable, very steady, 24/7, 365. That's been the experience, especially for most customers. Of course, in the AI world, that might probably move a bit, but again, there are so many different ways to move traffic to the right data center and keep the load levels high. So energy storage starts becoming a very interesting aspect in the data center space. The second play is about low carbon construction. We all use a lot of concrete in the buildings, and clearly concrete is a large play in terms of embodied carbon. And so what other alternatives are available in terms of constructing a data center using less embodied carbon? Assuming that we have renewable energy, it's still important to be responsible for the usage of the energy. And so efficient use of energy becomes extremely important, irrespective whether we are talking about the energy losses in the powertrain or the requirement for energy in terms of heat extraction or cooling. And finally, there's a lot of resources in the data center. How efficiently are these resources being used? Not only energy and material, but even the manpower. And that is the final axis that I would like to talk about today, especially in terms of the green operation. So looking at the energy supply into the data center, at Huawei, because we work a lot on the renewable energy side, we also work on the energy storage side of the business. We've been able to look at a lot of these business cases and today have multiple sites or cases around the world leveraging the best of renewable energy and energy storage. So it's all about working with the grid, with private players to make sure that you are able to, as a data center builder or a data center operator, to get green energy or source green energy from those suppliers. Most of these suppliers today are looking for players to add on to the supply energy storage. Now, obviously, we are looking at the hydrogen promise in the future, or solid oxide energy storage. But currently, the easiest, most efficient energy storage system is the lithium battery. And that is what we are seeing being adopted across the data center space. So as you come closer into the data center campus, we are seeing many players looking at reducing or actually removing the diesel generator from the data center. Easier said than done. This is more today aspiration. But the fact that we are seeing new RFPs or customer requirements asking for concepts is, can you remove the diesel from the data center? Is a space where energy storage becomes very important within the data center. And that's what we are seeing here in terms of energy storage at megawatt levels. The other thing we are seeing is doing power conversion at a medium voltage level. Most UPSs work at low voltage. And at low voltage, the I square R losses are much higher. But if you were to do voltage conversion, power conversion at medium voltage, your I square R losses drop very quickly. And that further improves the efficiency of your electrical train. So medium voltage UPSs, energy storage on site, use of more green energy, those are some of the elements that help us to make sure that we are as green as possible on our data center cluster. On the construction side, the traditional construction, which is pretty much you design the building, you contractors then deploy the construction, and you fit it out with all the MEP. It's a sequential process. It's a time-consuming process. Most of the industrial construction has a lot of wastage also, wastage of materials, water, electricity, because the construction is done on site. If, however, the construction is done in a factory and assembly is done on site, then the factory environment is more a production environment. And so the wastages can be reduced. And on site, you then are only assembling the data center. So this is an approach that we have been working on for the past almost a decade. And today, we have close to 200 plus megawatt of data centers built using 100% prefabricated construction technology. I must add here, it's not only prefabricated, it's prefabricated and pre-fitted. Because prefabricated has been in the industry for very long. The challenge in the data center is 70% of the cost and time is in the fitting out of the data center. And so it's not just the prefabricated structure, but that structure is also pre-fitted with the MEP in the factory. Obviously, you can't pre-fit everything, but close to 50 to 70% of the MEP fit-outs are fitted out at the factory, thus making the on-site work much lesser, much simpler, much more predictable, and not to mention, the whole process is extremely fast. Today, we are able to deploy data centers of almost any size between 10 to 14 months. So you give me a piece of land, 14 months later, you have an operating certified data center running. And that's the play here. Steel, as we know, has much less embodied carbon as compared to concrete. So not only it has lesser embodied carbon, it has lesser construction wastage, and it has a much higher speed in terms of delivery. You're seeing some of the real construction videos here, and what you are seeing here is all has been fitted, is in place, and is in operation for the past few years. We then took the learnings from our prefabricated concepts, and we said, okay, a prefabricated building may not work for every scenario. If you want a 6-meter high white space, clearly we can't do it with a prefabricated structure because it's not easily possible to ship a 6-meter high structure on a ship, off a truck, and so on. So clearly there are certain scenarios where it works very well, but then there are many scenarios where it may not fit the bill. However, there are some elements of prefabricated concept that can work very well, even if your data hall requirements are 6-meter or 5-meter, or the column-to-column length is 16-meter, and so on. You can design the white space the way you want. Steel structure, concrete structure, traditional. However, the more complex electrical rooms, cooling corridors can be prefabricated. And they can be attached to the traditional building. So the architect can design in such a way that it's a hybrid method. You have some parts of the building built in the traditional manner, and some parts of the building come in a prefabricated manner. Especially the powertrain. This is the most complex part of a data center. This is where most of your CapEx is in the data center. And this is also most time-consuming in the data center. And if the whole electrical system is on a single rail, it becomes very easy to build out the electrical room. What you see here in the picture at the bottom is the whole electrical train on a skid, right from medium voltage input, including a transformer if the local utilities allow, all the way down to main distribution. All on a single rail, pre-fitted, pre-structured, pre-bus, pre-tested. So when you come to the factory, you don't do a FAT for a product. You do the FAT for the whole electrical room. You do FAT for the whole electrical line. And so your performances are much more predictable. You are able to get a more performance-backed solution and not something that is assembled on site. What we've seen is this also is able to reduce a lot of our footprint. This footprint that is now the electrical room, you save on the footprint by 20, 30%. That 30% extra floor space now can be used for the white space, more sellable space where you make your revenues. It drops down the time by almost 75%. We take a couple of weeks now to put the whole electrical room in place, which normally takes a few months. Because it's designed and assembled and tested as a system and not as a product, there's a lot of embedded IoT inside. And so all of that performs as a single system and gives you a lot of visibility, a lot of ability to monitor, measure, and obviously manage. And finally, using the right level of algorithms on all of this data that is available, we are able to predict failures. Most of the failures happen over time. The challenge is our traditional methods of detection don't help us to detect or trigger these alarms, simply because at lower loads, the temperature rise will never be enough to trigger an over-temperature alarm. But an AI calculation can calculate that the temperature rise is much higher as compared to the load increase. And so therefore something is wrong, which is a trigger to go out there and check it out. And similarly, oral sensors, audio sensors. So you can have sensors that can smell oil leakages. You can have cameras which are looking at your data center and software that can study the images and tell you whether this is an oil leakage or a water leakage. You can have an audible sensor that can distinguish between a noise of a ball bearing of a fan and tell you that you may have a fan failure, impending fan failure in this area. So a lot of capability is possible and available. We then started to look at, and by the way, this is a very popular solution set. In fact, at an average, we do somewhere between 50 to 80 megawatts a month worth of these electrical rooms are supplied globally to our customers. We then looked at the cooling part of the solution. Cooling, while it may not have the same value in terms of capex as the electrical system, but it is sometimes even more complex than the electrical system with all the piping and the elements that are required to put the cooling system together. And this is where we started looking at, can we converge the whole cooling system in a box? So instead of having so many different elements that contractors have to put in place to put together the cooling, we just bring in a single converged system, attach it to the building, and you have certain kilowatt, megawatt of cooling capability. And that's what you see here on the right-hand side. This is a converged cooling pod, which is basically has 3 modes of operation: free cooling, adiabatic assist, and DX mode. Today, this is a very popular cooling system, especially in areas where free cooling can be availed. Of course, doesn't work in every part of the world, especially not where I live. We then looked at how do we improve the availability of the cooling solution. You must have seen over the last 10 years, almost every vendor talks about EC fans, electronically commutated fans. This is nothing but electronic controller embedded in the fan motor so that the fan can be controlled steplessly, and therefore you have much better control and efficiency of the fan. If you then look at the last 10-year failure rate of the fans, you will find that almost 90% of the fan failures, 93% of the fan failures are because of this electronic commutative system inside the fan. But when this fails, you've got to replace the whole fan. And so the question is, it takes a few hours to replace a fan. You need to get the whole fan shipped from the service center or the factory, wherever it is built. So what we've done here is we've taken the electronic commutator out of the fan. And the electronic commutator now is like a hot pluggable, swappable electronic module. So if at all it fails, it takes 5 minutes to swap. It's the least intrusive process. You don't have to do anything with the fans. Another example, today, if you want continuous cooling, you use UPSs to back up the fans. You use UPSs to back up the What we have today is battery-backed inverters, battery-backed speed control inverters inside the system. So today, this module that you saw on the left has battery integrated into the module. You don't need any UPSs. You get continuous cooling depending upon the timing that you've chosen in terms of the backup. So some of these solutions are gaining a lot of traction. And then fan walls. race floors have slowly, almost most surely gone out of the data center. It's all horizontal airflows, 250, 300, 400 kilowatt fan walls. Today, we have fan walls that go all the way up to 400 plus kilowatt, built in a complete modular fashion. All services done only from the front or from one side, which basically means you could stick these fans up all on the edge of the data hall and ensure that you have a much better air dynamic, not to mention ease of services. And all of this operates at higher chill water temperatures. I was yesterday talking to some of the folks who've been in the industry for very long, and I remember my early days. I used to come to Amsterdam in 99, 2000 to sell to Global Crossing, and those days KPN Quest. And I was talking to some of the folks that I know since that time, and we were sharing about what is happening on the temperature inside the data center. And already the conversations and the SLAs that are being signed are going up. Today it is not anymore 18 to 27. It's all going now from 18 to 32, which means you would be able to operate your data centers at 28 degrees. And this is where the industry is going. So as we keep pushing the envelope here in terms of the temperature set points within the data center, you clearly will see better cooling performances, the need to have cooling which is more flexible, and the cooling which is more modular. With both the electrical system and cooling systems converged, you create an opportunity to embed it with a lot of sensing. I can sense now almost anything in the electrical system, from temperature on the bus bars to temperature inside transformers to temperature on circuit breakers, you name it, to pressure gauges, to speed of fans, compressors. There are sensors everywhere. All of these sensors provide a lot of information. So to give you an example, today most of our cooling systems have refrigerant leak detection system. So you're 24/7 looking at refrigerant levels, and we can raise alerts if the refrigerant levels have gone down. So the alerts come in much earlier so as to take corrective action before you have any compromised operation. Same thing on the electrical systems, on the battery systems, on the diesel systems. All of this is allowing us to manage things remotely. If you then add the machine learning layer on top of it, you get predictable analysis. You are now able to predict what will happen in the data center and accordingly move in much before the maintenance cycles that you otherwise would be using them. Also, it allows you much smarter resource management. When you have so many resources, the understanding of the operational aspects of the resources in terms of wear and tear, warranties, maintenance, people, who is doing what, how many hours is he loaded, and so on. All of this helps in much smarter resource utilization. And we believe going forward, these machines will also be used for energy scheduling. Today, cost of energy is different by the hour. You may be able to pick renewable energy at a certain point in certain period of time during the day. You may have a better available energy source for a certain time of the day. You may want to use your batteries, to offset some of the, peak tariffs. All of that will require a software play, which probably could use even blockchain for contract negotiation and be able to schedule the energy in terms of the best source, the best available, the most green, the most cost-efficient source at that point in time. So clearly, a lot of capability is being built into the data center space. Finally, I want to close out by showing you a couple of pictures. Some of the folks in this room who would have probably visited these sites, but this is a site in Dubai. This is a data center, a co-location campus owned, operated by the local utility. The local utility has a 1.6 gigawatt solar power plant. 1.2 gigawatt is PV. Around 400 megawatt is CSP, so that operates in the night, molten salt-based plant. And this data center is part of a 100 megawatt plan. This is a 36 megawatt campus, what you see here. And this data center, at an average, based on what the customer wants, the delivery timings currently are about 12 months. From the date of signing to delivering a pod is about 12 months. Everything that you see here is 100% prefabricated, except probably some of the substation rooms and water tanks and stuff like that. This data center, a few months back, was also in the Guinness Book of World Records for being the largest 100% solar-powered data center. I think I said it right, too many words. This is another large co-location, tenanting a hyperscaler. This is using a free cooling solution. All the free cooling modules are mounted on the rooftop. And this is, if I'm not mistaken, an 8 megawatt building. So there are multiple buildings on the campus. Each building is about 8 megawatt. What's unique about this is we have 2 sites in the same city, in Dublin, about 10, 12 kilometers from each other. But both sites have different tenants and different SLAs. This particular site, the SLA, has a higher operating temperature in the white space. So the machine, the free cooling machine, was modified to remove the DX. So it only works on free cooling and to some extent for some hours of the year on adiabatic assist. Whereas the other site, which is about 12 kilometers away, the tenant does require 1827, and so it has the DX portion. So again, a lot of flexibility available in terms of what we can do in this space. So that's pretty much from my side. Thank you very much. My team and I are available outside. If you have any questions, you're more than welcome. Have a great day.